Hi everyone, welcome to the third session of the stereochemistry of organic compounds. Myself Sumalata S. Assistant Professor from the Department of Chemistry, SKNG GFG College, Gangavati. In this session, we will going to discussing about the geometrical isomerism, stability of the geometrical isomers, and the EZ nomenclature for the geometrical isomers. Let's begin the session. Geometrical isomerism. What is the mean by geometrical isomerism? It is the isomerism exhibited by compounds having the same molecular and structural formula, but they differ in spatial arrangement of atoms or the groups around the doubly bonded carbon atoms. Means here the groups are the atoms which are attached to the carbon atom. Those are involving in the double bond formation. Their spatial arrangement is different. Due to that, there arises a isomerism known as a geometrical isomerism. The compounds having the similar or the identical groups on the same side are termed as a cis isomers. The compounds having the similar or identical groups on the opposite side are termed as trans isomers. Next, the properties of the geometrical isomerism. These geometrical isomers differ in their physical properties and chemical reactions. The presence of double bond restricts the rotation and also a change from one form to the another. Means here, due to the double bond, there is a restricted to transform cis isomer to the trans isomer. Hence, there is a differ in the physical and chemical properties of the isomers. The geometrical isomers are not mirror images of each other. Therefore, they are not enantiomers, but they may be considered as diastereomers. Means diastereomers are the non-mirror images of each other. Okay. Next, coming to the examples. Here we are considering the malic and fumaric acids, and these can be represented as a cis and trans forms. One is the fumaric acid, that is here the IUPAC name for this compound is the butane 1,4 dioic acid. Okay, here what happens? There is a one COOH group attached to the one carbon atom and other COOH group attached to the another carbon atom involved in the double bonds. But here in case of fumaric acid, there is a COH group. One COH group is present above, another COH group is present below. Means the bulkier groups which are in the opposite side. Hence, this is termed as trans butane acid. Okay. Whereas in case of malic acid, the COOH group, the bulkier COOH group is present on the same side. Hence, this is termed as a cis isomer. This is the cis butane acid. Okay. In geometrical isomers, if the bulkier groups is present on the same side, means those are termed as the cis isomers. If the bulkier groups are present on the opposite side, means those are termed as trans isomers. Okay. Next, stability of the geometrical isomerism. How these geometrical isomers are stabilized, are the what factors affecting these stability of the geometrical isomerism. First, the geometrical isomers, also known as cis and trans isomers, exhibit differences in stability. Generally, the trans isomers are more stable than the cis isomers due to the reduced steric hindrance. The steric hindrance occurs when the bulky groups in the close proximity repel each other. Okay. Here, see here. In case of cis isomer, the two bulkier groups are present in the same side. Due to this, there is a more steric hindrance. Okay. Hence, this increases the energy of the molecule. Due to this, there is a decrease in the stability of the cis isomer. Okay. But in case of trans isomer, the two bulkier groups which are present in opposite direction. Hence, there is a decrease in the steric hindrance or the repulsion. Hence, these trans isomers having the lesser energy. Due to this, these are more stable. Okay. Trans isomers are more stable than the cis isomers. Okay. And also, beside this steric hindrance, the factors like electronegativity and electronic effects can also influence the stability of geometrical isomers. Okay. Here, for example, in case of cis-2-butene and trans-2-butene, here what happens? In case of cis, the two methyl groups, bulkier groups on the same side, and there is a more repulsion and more steric hindrance. Due to this, the energy of the molecule goes on increases and there is a decrease in the stability of the molecule. But in case of trans-2-butene, the two bulkier groups which are present in opposite direction, hence there is a less steric hindrance and this stabilizes the molecule. Hence, the trans-2-butene is more stable than the cis-2-butene. Okay. Next, coming to the EZ nomenclature. What is this EZ nomenclature? It is easy to name the geometrical isomers if the two groups are identical. Okay. But when all the four groups are different, then the nomenclature of geometrical isomers becomes difficult. Hence, a new system of nomenclature of geometrical isomers called EZ nomenclature system has been introduced to name the geometrical isomers with the four different groups. Here, E means, in the German word, E means antigen, means opposite side, means this is E isomer is used to represent the trans isomer. Next, Z, in the German word, it is the zusammen, means follow together or in the same side. Okay, bulkier groups on the same side. This Z representation is used to represent the cis isomers. Okay. Next, in the EZ nomenclature system, configuration are assigned according to the following sequence rules. Okay, here we are going to prioritize the molecules depending upon the rules. Okay, if two groups having the higher priority are present on the same side, then this is termed as a Z isomer. If the two groups which are prioritized as a higher priority which are present in the opposite side, those isomers are termed as a E isomer. Okay, next, rule first. What is this rule first says? Priority is assigned based on the atomic number of the atoms bonded directly to the sp2 double bond carbon. Larger the atomic number, higher the priority. Okay, what happens? What is this rule says? Here, if the molecule or if the atom are a group of atoms, we will consider those atomic number. If the atomic number is higher, then that will get the highest priority. If the atomic number is lesser, then that will get the least priority. Okay, for example, see here, sulfur. Okay, oxygen. What is the atomic number of oxygen? 8. Nitrogen 7. Carbon 6. Hydrogen 1. So, if the atomic number is more, then the priority also more. If the atomic number is least, then the priority also least. Okay, here we are considering the 2-pentene. Here there is a CH3 group, one hydrogen group attached to the one carbon atom involved in the double bond. To the other carbon atom, one is ethyl group, other one is the hydrogen group. Then consider the labeling. Okay, how we are going to label or prioritize the highest atomic number. Okay, which one is having the highest atomic number, that will get the more priority. So regarding this hydrogen and CH3, hydrogen is atomic number is 1, CH3 carbon's atomic number is 6. Hence this is the more prioritized one, it will get the 1 first priority, hydrogen will get the second priority. Similarly here also, here one is ethyl group, other one is hydrogen. Hydrogen atomic number is 1. Here the carbon atom which is attached to this double bonded carbon atom, here this carbon atom has the priority, what is atomic number is 6. Hence this as the priority 1 and this is the priority 2. Okay, see here. Next what we have to do, we will going to name this isomer. How we are going to name? We will consider this as either E isomer or the Z isomer. How we will going to consider? In case of E isomer, the two highest priority groups are present on the opposite side. But in case of Z isomer, highest priority groups are present on the same side. Okay, let's see here. What is the case here? Here two highest priority means first priority groups are present on the same side. Hence this is the Z isomer. Hence it is a Z2-pentene. Okay, so next, coming to the second rule. What is this second rule says? If the two groups bonded directly on sp2 carbon, it is the sp2. Okay, sp2 carbon start with the same atom. Okay, it means there is a tie from the step 1. Okay, in first step what we are going to considering here, this is the first hydrogen. Here what is the atom bonded to the double bond? Carbon. Okay, in this step hydrogen carbon, this is having the highest atomic number, hence this will get the first priority. Here also this is hydrogen and this is carbon attached to the double bonded carbon, hence compared to hydrogen, carbon is having the highest atomic number, hence it is get the first priority. Okay, here two different atoms are attached, hence we will consider the atomic number. If same groups attached, see here also carbon, here also carbon, right? Here also carbon attached to the double bonded carbon, here also carbon attached to the double bonded carbon. Then how we are going to naming this? We will prioritize, increase as the atomic number of the next attached atom. Okay, here how we will going to prioritize here what is the compound? CH3 group. Okay, to a double bonded carbon atom, one carbon is attached. For this double bonded carbon atom, two carbons are attached. Okay, one carbon cancelled, but here one more carbon, here hydrogens only present, hence this is getting the highest priority. Here what is the case here it is the chlorine atom, here it is the carbon atom. Okay, so compared to carbon and chlorine, which one is having the highest atomic number? Chlorine, hence chlorine will get the first priority. Okay, see here, in this case how you going to decide what is this isomer? Here the two highest priority groups are present in the opposite direction, hence this is the E isomer. Okay, this is the E isomer. Understood? This is regarding the rule 2. In the first rule, it says depending upon the atomic number of the atoms attached to the double bonded carbon atom, we will going to prioritize. But in case of rule 2, if the two atoms attached to the carbon atom involved in double bond are same, then we are going to prioritize with the next attached atom. Okay, hence this is the E isomer. Okay, next, on the basis of these rules, E and Z nomenclature, we will going to discuss some more examples. See here. Okay, this is the 1 bromo, 2 chloro, 2 fluoro, ethene. Okay, it is first carbon, this is the second carbon named as a. Okay, for this first carbon atom, what is the elements attached? One is the hydrogen, other one is the bromine. Okay, so this is the first one, this is the second one. Next, for the second carbon atom, what is the groups attached? One is the fluorine, other one is the chlorine is attached, right? How you, in case of IUPAC nomenclature, how you going to name this compound? It is the 1 bromo, and here how you are going to consider fluorine and chlorine? This is according to the alphabetical order. Which one comes first in the alphabetical order, we will name that one. Okay, here it is a chlorine and bromine, so C comes first, hence we will going to name first C. Okay, and also we will consider the position of this chlorine atom. Okay, this is the first carbon, second carbon. We will consider the position of this chlorine atom. Position means it is attached to the second carbon atom. Hence, it is the 2 chloro, 2 fluoro, and how many carbon atoms in the main chain? 2 carbon atoms. Hence, it is the eth. Due to the presence of double bond, it is ene. Hence, the name 1 bromo, 2 chloro, 2 fluoro, ethene. Okay, this is the IUPAC name. Then, how you going to represent this E and Z isomer? We will going to prioritize the groups. Okay, here we are using AB as the representation for the representation of the priorities. Okay, see here, consider this carbon atom. Okay, this first carbon atom. Here, what are the groups attached to this carbon? One is the hydrogen, other one is the bromine. Depending upon this, which one is having the highest atomic number? Bromine is having the highest atomic number than compared to the hydrogen. Hence, bromine gets the first priority A, and hydrogen will get the least priority. It is represented as a B. Okay, coming to the second carbon atom, what are the groups attached here? One is the chlorine, other one is the fluorine. Okay, next, how you going to prioritize this? Here, chlorine has the highest atomic number than compared to the fluorine. Hence, chlorine gets the highest priority. Hence, it is represented as a and fluorine gets the least priority. Hence, it is represented as a B. Okay. Next, see here, the next what we have to do? We have to consider where the highest priority groups are present. Okay, see here the highest priority group is this one. Here highest priority group is this one. Okay, two highest priority groups are present in opposite side. Okay, if the highest priority groups are present in opposite side means it is the E isomer. Okay, here in this case the two highest priority groups are present on the same side, then this is the Z isomer. Okay, next example is the 2-pentene. This is according to the second rule. Okay, see here, no, this is also regarding the same rule, first rule. How you going to consider here? Here, for this is the first carbon atom, this is the second carbon atom. Okay, here consider this one is the first one group and this is the another group attached to the first carbon atom. One is the carbon atom, other one is the hydrogen. Okay, depending upon the atomic number, here carbon is having the more atomic number than the hydrogen, hence it has the highest priority. It is considered as A and hydrogen is considered as B. Okay, here for the second carbon atom, what are the groups attached? On one side it is the hydrogen, on the other side it is the ethyl group. CH2 CH3 means it is the ethyl group. Okay, for this second carbon atom, initially what are the elements attached? One is the hydrogen, other one is the carbon. So what is the priority? The carbon will get the more priority than compared to hydrogen, hence it is the A, it is B. Okay, next, see here in case of first carbon atom, this is the highest priority. For the second carbon atom, this is the highest priority. Okay, two highest priority groups are present in the opposite side, hence this is the E isomer. Okay, here in this, see here, the two highest priority groups are present in the same side, then it is the Z isomer. Okay, next. See here, in case of 3-ethyl, 4-methyl, 2-pentene. Okay, here, see here, for this carbon, first before going to naming the compounds, we have to derive the structure for this compound. Okay, here these are the two given structures. Here this is the first carbon atom, this is the second carbon atom. Okay, double involved in the double bonds. Okay, for this carbon atom, first carbon atom, what are the groups attached? One is the hydrogen, other one is the methyl group. Then here this is carbon attached. Compared to carbon and hydrogen, this is having the carbon is having the highest atomic number, hence it will get the highest priority, hence it is the A, and hydrogen is represented as a least priority B. Okay, coming to the next carbon atom, what are the groups attached here? See here one is the ethyl, here second one is the dimethyl. Okay, groups attached, two methyl groups attached to the carbon atom. Okay, it is the methyl ethyl. Here, see here, what is the, it is according to the second rule. What is the second rule says? If two atoms attached to the carbon atom involved in the double bond are same, then we will going to the second next atom attached to that carbon. Okay, see here, for this, here this is the carbon atom. Okay, to this carbon one more carbon is attached. Okay, but here what happens? Here CH3 twice. Okay, to this carbon two other carbons are attached. For this carbon, one carbon attached. For this carbon, two other carbons are attached. Hence, what is the priority? Here, it is the more priority. It is the less priority. Okay. Means, here, the two carbon are attached to the carbon atom involved in a double bond. Hence, those are same. Hence, we will going to concentrate on the next atom attached to this carbon. Okay, here to this carbon only one other carbon atom is attached, but here to this carbon two other carbon atoms are attached. Hence this is the more priority, this has the least priority. Okay, next coming to the isomers, E and Z isomers. Here, see here, this is the bulkier group. Here highest priority one. Here this is the highest priority one. The two highest priority groups are present in the opposite side, means this is the E isomer. Here this is the priority group. This is the another highest priority group. The two highest priority groups are present in the same side, means this is the Z isomer. Okay. Next, coming to the next example, 2-chloro, 3-methyl, 2-pentanoic acid. Okay, these are the given structures. See here how you are going to classify these one. Here, considering this carbon as a first carbon, this carbon as a second carbon involved in the double bond. Okay, these are not according to the IUPAC names. These are just for the our namesake to represent this isomers. Okay, for this first carbon, what are the groups attached? One is the chlorine atom, other one is the carboxylic acid COOH group. Okay, first we will consider the first atom. It is chlorine. Here it is the carbon. Okay, it is carbon, it is chlorine. Okay, according to the atomic number, which one is having the highest atomic number? Chlorine is having the highest atomic number, hence it will get the more priority, hence it is represented as a. Because of a least priority, this is represented as a B. Okay, next coming to this next carbon atom. Here to this carbon atom, one is CH3 group, other one is ethyl group. Okay, which one has the highest priority? Ethyl has the highest priority, hence it is represented as a and this methyl group represented as a B. Okay, next see here, after designating the priority, we will going to know which one is the isomer. See here, this is the highest priority one. Here this is the highest priority one. Okay, so what happened here? The two highest priority groups are on the opposite side, hence it is the E isomer. Okay, in case of this isomer, here this one is the highest priority. For this carbon, this one is the highest priority. Okay, two highest priority groups are on the same side of the double bond, hence this is the Z isomer. Okay, this is regarding the EZ nomenclature and some of the examples. I think you all understood this concept. Next, coming to the third rule, that is geometric isomerism in oximes. Okay, in case of oximes, how we are going to naming these geometrical isomers? If in a compound, one of the double bonded atom is not having any substituent. Okay, see here, this is the oxime structure. Here only one side we will get the have the group, but on the other side there is no any groups are the substituents are present. Okay, in this case, how you going to name these compounds? While deciding the priority, the vacant position is considered to have an atomic number 0. Okay, see here. Here first for this carbon, okay, for this carbon, one is the benzyl group, other one is the hydrogen. Okay, so compared to this hydrogen, carbon is having the highest atomic number, hence this is the benzyl is get the highest priority. Here this will get the least priority. Okay, next for this it is consisting of the only one substituent, other side is vacant, hence this is considered as the atomic number of 0. Okay, so hence this only gets the highest priority, this will having the least priority, and this is the vacant side is B. Okay, see here this is the highest priority one, here this is the highest priority one. The two highest priority groups on the opposite side means this is the E isomer. Coming to this, here this is the highest priority and this is the highest priority. Two highest priority groups on the same side means this is considered as a Z isomer. Okay, this is regarding the third rule. Okay, this completes the EZ nomenclature of the geometrical isomers. Okay, by end of this session we came to know that what are the geometrical isomers, what are the types of the geometrical isomers and how these geometrical isomers are stabled, and EZ nomenclature of the geometrical isomers. Thank you for watching.